Welcome to Ask and Learn.
The first step in this problem is to write out the oxidation reactions of both iron and aluminum metals into their respective metal oxides. Starting with the oxidation of iron, when iron and oxygen form a metal oxide, it's usually between iron 3 plus and oxygen, which always has a charge of 2 minus. So when we combine those into a compound, it's Fe2O3. For aluminum, we also use 3 plus as a charge. So this is Al2O3. And both of these are solid metal oxides that are forming. Oxygen has bonded to these metals and formed an oxide. And now we need to balance each one of these equations. If we begin by looking at the number of oxygens on each side, we see that we have 2 oxygens on the reactants and 3 on the products. In order to use whole numbers, we need to balance out 3 O2s to get 6 oxygens and 2 Fe2O3 to get 6 oxygens, which leaves 4 iron solid on the reactant side. And these end up being the same stoichiometric coefficients we use for the oxidation of aluminum. And now we want to determine, using delta G of formation values, which one of these processes is spontaneous at standard conditions of 298 Kelvin. And so since these are both formation reactions, the change in Gibbs free energy of formation at standard conditions for the solid metals and diatomic oxygen are both 0 because they occur naturally and there is no change in energy required to form them. So for each one of these, we are only going to be examining the two moles of the metal oxide that form in each case, because we are taking the total change in Gibbs free energy of the products and subtracting the total change in Gibbs free energy of the reactants. But we know that since this is a formation reaction, delta G of formation at standard conditions for the reactants is 0. So we are only concerned with the products. And starting with the oxidation of iron, we form 2 moles of Fe2O3. We can look up that delta G of formation value for that compound. And because delta G of formation for the reactants is 0 in a formation reaction, we can see that this comes out to this negative value for delta G of formation of that metal oxide. Similarly, for the oxidation of aluminum, we form 2 moles of Al2O3, which has its own value for its change in Gibbs free energy of formation at standard conditions. And again, due to the formation reaction, the delta G of formation of the reactants is 0. And so delta G of formation is equal to that value that we just calculated. Remember that for a reaction to be spontaneous, delta G has to be less than 0. It has to be negative. And in each one of the delta G of formation values that we calculated, we see that both of them are negative. So we can conclude that both the oxidation reactions of Fe and Al are spontaneous. Spontaneous reactions do not require any input of energy in order to form the products. And this is what we should expect, because these equations represent the rusting of metals over time. And we know that we have metals like iron and aluminum exposed to oxygen, that over time rust will form in the form of these metal oxides. And that occurs naturally. It does not require any input of energy. So we should expect both of these processes to be spontaneous. And we can verify that with these negative values of delta G.